Some companies store passwords as plain text, so readable text. If you search the internet for words plain text news, you'll find that some companies just store all of the passwords in a readable text file. Depending on, of course, the news. And so instead of storing text in readable text, what companies do many times is calculate so-called hashes. So one password, every password or every word can map to a single hash, which is unreadable text, and it's hard to derive from it's a one-way function, right? So with the program, it's easy to go from input to output, but from output, it is basically impossible to go to input. So what many companies and systems do is store their password as hashes. And even your system you're using now, so whether you're using Windows, Linux, or Mac, they store all your computer's password as hashes and not as readable text that you can just read in a text file. So how does this hashing work? For example, here we have the NTLM or the Windows hasher. So you would have a password, let's say password. It goes through that function, whichever function is specified by the company or the system, and then it calculates the hash. You'll see calculate hash, and it turns into this hash. So let's take a note of that. So password maps to this hash. And if we try it again, you'll see it's exactly the same hash. So same input in this hashing function always generates the same output. However, if we have a small change, for example, capital P password, you'll see that changes the hash completely. So it doesn't depend on time, it just depends on the input, but every input has a unique output, a unique hash. And why is this important? Because any system, any modern system, stores those passwords as hashes. So you'll see it stores whatever password you have as its unique hash. And every word has a unique hash. So the output is unique for every input. But it's hard to go back, right? If you have any of those hashes, it's hard to go back. And it's possible there to use different hashing algorithms here. For example, there's many different hashing algorithms or hashing programs. So you'll see, depending on which program we use, it creates a totally different hash. But the hash will always be the same. It's not dependent on time. So that is what hashing is. Basically, it's a function where the input text is converted into an unreadable value. And we need to know if usually we discover those values. For example, if you dump passwords on Windows or Linux, those passwords are stored as a hash value. And you can crack those hashes. For example, let's take one of those hashes we just created and head over to crackstation.net. And we'll type in the hash. Click I am not a robot. Okay, we have this annoying thing. Click crack hash, and you'll see it cracked the Windows password. So this hash to be password. So we can take that for any hash. And in Crackstation we can crack those hashes. So you'll see it returns example for that password hash. So the way it works is Crackstation has billions of passwords stored. So it runs a dictionary through this hash function and then has a mapping for input-output. So it just scans if it finds that hash in the database. It is not possible with Crackstation to crack any password. However, with a list of 1.5 billion words and password hashes, it's likely that you can find it. So this is what hashing is. It's basically a different way to store passwords, and they are created using a hashing function. And the idea is that if you have a hash, it's very hard to get the original password back. But there have been many hackers and who create, for example, backstation.net, where you just paste in the hash and find the resulting passwords. So we'll get more into that into next lectures.